I'm going to begin with some background and my ties to this unique area. And then the talk will be broken into 3 parts. And part 1 is the current state. Oops, there's a pop up there. Part 1 is the current state of what's happening now with mining, and that that part will be me presenting some of the data from the Northern Lights Scientific Advisory Panel. Part 2 is it's going to talk a little bit more about the copper sulfide mining threats, but also the difference between iron oxide and copper sulfide, which is some of the research I have. And then part 3 is the sustainable alternatives. And that part will be a little bit from my Lichen Labs kind of hat here, and another from reclaiming critical metals. And I'll mention what all those pieces are as we go along. So I'm Sue Okerstrom. I'm an innovator, material scientist, and biomimicry professional, and I'm founder and chief technologist at Lichen Labs. Oops, I was afraid of that. Lichen Labs specializes in microscopy services and biomimicry research for new product design and education. We also do special projects for academics and artists. We moved from the Minneapolis area to Duluth in this past year. So today I want to speak about northeastern Minnesota, including the Boundary Waters Canoe area that's shown in this picture. Minnesota is a state in the center of the United States, there in or center of North America, that's shown in red. There's Minnesota. And we want to talk about northeastern Minnesota. And we share a border with Lake Superior and Canada. And Lake Superior is the largest freshwater lake in the world. And we have the BWCA up at the top here. And the picture that you just saw, and many of the pictures that I will show came from this area here where the star is way up near the top of Minnesota. So BWCA is there, and Voyageurs National Park wilderness areas. At the center here is the Mesabi Iron Range with the towns of Hibbing and Virginia. And then there's Ely here that is in the Vermilion Range. It's the gateway to the Boundary Waters, as well as where an early underground mine was located. And it's the reason that I'm here today. My great-grandfather, Giuseppe Maganini, emigrated from Italy to work in that mine, which operated from 1889 to 1965. This is the underground mine. This is a sketch that I did. My sister was writing a book about mining and early days of mining and our family connections to it. So this is one of the illustrations from that. So Giuseppe Maganini, he's pictured here in 1905 on the right, emigrated with his cousins, Caesar Mondavi and their families, to Ely, Minnesota in 1910 to work in that underground mine. This is his writing that I found recently. We're selling our family home that he built in 1915 in Virginia, Minnesota, and found a lot of interesting pictures and other things. And so we can see where he came from in the city of Rosora. I'm not saying that right, Rosara, in the province Ancanta. And it was a wine growing region. And eventually went from Ely to Virginia, Minnesota, as did the Mondavis. And they went on to California, to Napa Valley, and started a wine empire. And they sent grapes back to my great-grandfather. He had built a wine press, and he began making wine in 1922. And he had 7 children. My grandmother, Annie Ari Okerstrom with his parents from Finland. And my grandfather's father was John Okerstrom. He was an architect in Helsinki. And when he came, they left Finland because it was occupied by Russia, and he was going to be conscripted into the Russian army. So many immigrants came here for different reasons. And going on to my father, he spent 40 years at U.S. Steel in mining. And he was a lab analyst and a surveyor and a geological analyst. And then I worked in the mines as one of the first woman laborers to put myself through college in environmental science. And my focus in environmental science was ichthyology, the study of fishes, and limnology, the study of lakes. So in addition to having a history of mining, I come from a family of hunters and fishers. And I started fishing when I was old enough to hold a fishing pole. I'm pictured up in the top right image here. This is, and my sister is on the left. And this is my grandparents. And we were fishing on the North Shore. He was also a lineman with NAHR Railway. And the walleye here that is shown is a bottom feeder that eats organisms that have more methylmercury contamination coming through the food chain in sulfur polluted areas. Northerns are predators, and they're the highest mercury contamination because they're eating all the other fish. And the least contaminated are crappies, which are surface feeders. And I catch almost most of my fish at Lake Vermilion. Our cabin is at this star here on an island that we built in the lake. And the bottom picture here is me with my daughter when she was younger, and a pink salmon that was going upstream from Lake Superior that we had caught. These have much less mercury contamination. And she loves to fish and has continued to fish. This is a sketch that I made of her when she was a little bit older, catching a walleye on Lake Vermilion out in front of our island. And our island is pictured here on the right. Another valuable natural resource that is in the boundary waters near where the last picture was. It grows in the BWCA, but in hundreds of lakes, unfortunately, in Minnesota are repaired due to sulfate contamination over 10 milligrams per liter, which inhibits its growth. And it's a vital sacred food to the Native American tribes. And at one time, it grew throughout the state. So with that background on me and the area, I'm going to move into the three themes of the talk. So this first part includes the information about the water testing that we've been doing with the Northern Lakes Scientific Advisory Panel, NLSAP. That's our grassroots scientific group. Well, sulfate pollution from taconite mines, especially Mintac and ArcelorMittal in Virginia, flows to the Voyageurs National Park. Methylmercury contamination of walleye in Voyager Park is very high. It's a potent toxin for people consuming game fish. Mine waste from North Shore Mine in Babbitt is a source of sulfate pollution in the BWCA lakes. Minnesotans need to be concerned about the contamination that can affect pristine wilderness areas of the BWCA, Voyageurs National Park, and Lake Superior. And it must be protected from mining pollution. So this is the mission statement of the NLSAP. Our purpose is to provide data to Minnesota state agencies and support development of environmentally sound and economically productive guidelines for managing our resources in northeastern Minnesota lakes and ecoregions. We have a long list of accomplishments, and I'll highlight a few things that the most important that we've been by the Minnesota Pollution Control Agency to analyze water and directly upload our results to their database. And we've been doing water monitoring for sulfate in areas since 2015 and have come up with methods of testing sulfates for some of the BWCA lakes and testing mercury levels recently in the major Voyager parks. And the key piece I want to highlight that we're going to show in a minute is tracing the downstream flow of sulfate pollution from mining tailings for 175 miles from Virginia, Minnesota, through Voyagers Park, which you saw, up to the Canadian border. And in that study, it demonstrated that excessively high mercury lakes in Voyager Park are attributable in Walla to elevated sulfate concentrations. We also traced the flow of sulfate for 50 miles from Babbitt through the BWCA and have some early technical analysis of the Polymet mine area that it would be for copper. So this is a really important piece to show the uniqueness of place here. Everything is flowing, the water flow directions. These are all the continental divides. And the green one here, the Laurentian Divide, is just north of Virginia. And another divide, the St. Lawrence Divide, meets it right here, right near Hibbing. And it's the triple point about 2 miles from a current mine, Hallrus Mine. And they said it's a sacred area to the Native Americans. And if a drop of water lands in this area, you don't know if it's going to go north through the BWCA up to Hudson Bay or go southeast through the St. Louis River into Lake Superior and out through the St. Lawrence Seaway into the Atlantic Ocean, or south through the Mississippi River to the Gulf of Mexico. So pollution from mines in this area can contaminate major watersheds in many directions. So for NLSAP, we do water sampling and testing, and we follow sulfates from the mining tailings discharge through watersheds, and we take samples in the same area at different times of year from year to year, and we use GPS coordinates, and so we're within a very small area of getting the same measurements each year. You see, we're even doing this in a snowy time here, and we can do things like measure the cross-sectional area underneath a bridge where a river goes through so that we can determine the volume, and we measure the depth of the water. And here there's an orange we've thrown in the water, and the current will carry it under the bridge, and we can time how long it takes to go a known distance. And so using all of this data, we can figure out the total amount of volumes of contaminants that are going through. So we use we take 2 bottles samples in each location, and we have very precise ways for how we take the samples, and they can be from the shore, a dock, a canoe, the different boats. We've used lots of different methods, and it's interesting how uniform the sulfate is through the water column. And we were able to trace it for a long period of time, but you can get it nearer the surface or further down, and the amounts are the same. And then once we get all the data, then we can upload it we send it to an accredited lab, and then we can upload it into the MPCA database. And our results show that mines are releasing sulfate pollution into Voyagers Park and BWCA through the watersheds and causing alarming levels of mercury in game fish. And it's really unfortunate because it's such an important, pristine wilderness area, and Minnesotans consume contaminated fish that increases health risk, especially with pregnant women and children. And along northeastern Minnesota, 1 in 10 children born has an unacceptably high level of mercury in their blood. So we're going to talk about a study we did that recent 2 years ago, that for the first time we had correlated the mercury with the sulfate testing. And we want to talk a little bit about mercury and sulfate because mercury, elemental mercury, comes from the air. So we have coal-fired plant pollution that has mercury in the air. It can come from processing and mining processing. It can come from power plants. And so this elemental mercury, which is Hg+2, lands when it's in ionic form. And when there's sulfate present, bacteria, anaerobic bacteria, can methylate the mercury. A reaction takes place so that the mercury is in an organic molecule, and then it makes it available biologically so it can be stored in fat. And this is similar with other fat-soluble toxins like PFAS and PCBs. Methylmercury gets in the fats, and it can be magnified through the food chain. So the bacteria that have only a millionth of a part per million of methylmercury that are eaten by phytoplankton, and then that concentrates it. So now it's and up to where for zooplankton it's 1,000th of a part per million, and when we get to game fish, we're magnified 1 million times to the walleye to 1 part per million. So this is showing all the water is flowing and in current going north here from Mintac and ArcelorMittal taconite mines. So this is we'll talk a little bit more about the difference between natural ore and taconite, but this is taconite tailings, the waste that comes from hard rock iron mining, and it flows up this direction to Voyageurs Park and eventually reaching Hudson Bay, carrying mining pollution with it. So this map shows the path of sulfate pollution coming from Mintac and ArcelorMittal. So it's 77 parts per million here near the where the tailings is, and then it continues up. And the red areas on this one here are the parts per million of sulfate. The green areas are areas that we tested that are outside of the flow of the watershed that has tailings in it. This is the one coming from the mine in Babbitt that is going up into the boundary waters, and the other, it's North Shore Mine, and then the areas that we tested that are outside that flow. And here we've got the on the bottom here we've got the mileage. So starting from 0 up to 175 miles, all the way up to Rainy Lake, where we've done all this testing, and then the sulfate from 0 up to 25 milligrams per liter. So we can see that even though this looks like it's kind of the opposite, we're starting at Pike River here is 22, and then it's slowly the sulfate levels go down to where it gets to about 2.5 parts per million at Captogama. And away from that flow are isolated lakes and streams, and those are less than 2 parts per million. So we know that the sulfate coming from mining is causing those elevated levels. Oops, went too far. So here's the correlation. In addition to measuring sulfate, we also measured mercury in the water column, and we did some correlation between the mercury in fish here and the sulfate. And you can see that in Crane Lake, the walleyes are over at around a part per million, are worse than 64 of 65 commercial seafood species if we were to compare them, if they were to be on that list. And magnifies it. Here you are at 7 going down to 2.5, but that is enough to dramatically change the amount of mercury that's in the fish. So this equates that sulfate that is flowing away from the tailings equates to 3,000 tons of sulfate flowing into Voyager Park each year, that far away from the mine. And 10,000 tons of sulfate flow down the St. Louis River to Lake Superior every year. And fish in Voyager Park and St. Louis Estuary are heavily contaminated with mercury. So now we're going to move on to part 2, away from the NLSAP. And we're just going to talk a little bit.
Check, does anybody have any questions about the data so far? If you can always put them in the chat if something comes to mind, but I think we said since there's a lot of data, we were just going to check in with everyone, but Sue, I'll let you continue. Sorry to interrupt.
Oh, that's fine. Because I wanted to, part 2 is stopping a second and talk about the differences between what we're doing now with iron mining and what we plan to do or could happen in the future is the copper nickel sulfide mining. So iron oxide and copper mining, which is a sulfide, iron sulfide, they both involve extracting valuable resources from the earth, but they differ significantly in their geological settings, their mineral compositions, and extraction methods. Iron oxide deposits are typically vast and high grade and primarily consist of hematite and magnetite. The Mesabi Iron Range natural ore was 50 to 60% iron. So there's overburden that you have to get rid of in order to get to the area you're interested with ore. And so the ore that contains the iron, if you had a pound of it, natural ore, about a half a pound would be iron. And a lot of that high grade ore is gone now. That's what my great-grandfather came in mind, and my father started mining. I did a little bit too when I first started. And then we moved on to taconite as those deposits depletes, but it was still very high grade, but it's in a hard rock now that is 14 to 30% iron. And so it's like a shale that needs to be blasted, and then it goes through coarse and fine crushing until it gets down to like a face powder, and they add water, and then it flows through a magnetic separator, and then the iron is taken out, and that waste rock that it can have sulfur in it, it can have various things, goes into tailings ponds. So I wanted to take the time to explain a little bit about what that is. But like the natural ore mines that have been depleted, they are now lakes or reservoirs, because when mining occurs, both with natural ore and with taconite mining, you can get into the water table. Well, especially with, it depends on how deep you go, but, and when that happens, the mines are pumped out. While the mining is going on, the water is pumped out. And then afterwards, like with our natural ore pits, it's been allowed to fill up. And so the iron mines and iron oxide itself, you can eat it. Iron is very non-toxic, and pits have fish in them. Many of them have been planted with trout or with other fish. I once learned how to scuba dive in one of them, and we actually fed a fish underwater. So the differences with iron and compared to copper nickel is the copper nickel is a sulfide instead of those natural ores come in, or those ores come in contact with water, sulfuric acid forms. So it's a very high acid. And so that's a bit of background, but this picture that you see right now is the Berkeley pit in Butte, Montana. And that pit is very high acid. They were mining for a long time, and the average amount of copper that is in ore is very low. The global average is percent in a sulfide form. So when this Berkeley pit, when they quit mining, the organizations that owned them were mostly over. They didn't keep pumping the water out, and they allowed it to fill up both the underground mines and this open pit. And it's a very low pH. And over 3,000 snow geese died when a large flock landed on it. And so this is what can happen. The most dangerous part of copper mining is when the copper mining or nickel mining stops. And PolyNet acknowledged that when I was reading some of the early work, that they would have to continue pumping out the mine water and treating it for thousands of years, in infinity, 1,000 to 2,000 years. And so it's just it's a very high risk in an area like we have. And going back to the Berkeley pit, being a Superfund site, as the pit continues to fill up, they now are pumping it. However, they're trying to keep up with water that's flowing in from the water table. And if it gets too high, then it can overflow and contaminate the area. And in Montana, there's a lot less water, and it's not good, but still not as dangerous as an area that we are in now. And this is the PolyMet site that we're talking about. PolyMet and Tech Resources, which it's now called New Range Copper Nickel, is in the Superior National Forest, in a wetland forest area at the edge of the pristine water-filled wilderness. And so it's not a suitable site for high acid copper nickel sulfate mining. And it's the foreign owner is major owner is Glencore, that's in Switzerland. So that's the end of part 2. If you have any questions about that. Okay.
You can go ahead.
Okay. So now I'm going to move on to part 3, the sustainable solutions or alternatives, shall we say. We'll discuss alternative ways to fulfill the need of copper via reclaiming copper and other critical metals from electronic waste or polluted areas by various methods, including the possible use of biomimicry. So we're going to switch to a little bit more information that's coming through a company that we have formed called Reclaiming Critical Metals, with myself and 3 other partners. So this is a information from RECA, which is Reclaiming Electronics for Climate Action. And they're suggesting that a 20% increase in US copper recycling will eliminate the need for 13 PolyMet mines. And you're much farther ahead in Europe, that's already at recycling of 60%. But here in Minnesota, it's about 24% of electronics are recycling. And when we say electronic, we're talking about anything that's that you can plug in or has a battery, like a computer, a television. So those are called electronic waste. In 2023, the Iron Range Partnership for Sustainability and Recycling Electronics, Climate Action, and Macalester College published a pilot study about the economic potential for e-waste recycling. and they're lobbying the Minnesota legislature percent e-waste recycling bill. They've continued to push this forward and will again in the next legislative session. And you can see that in Minnesota, if we had 100% e-waste bill, there would be 1,738 direct jobs, 78 million pounds of valuable elements, and $3.2 billion of annual value. Now, a little bit about how e-waste is recycled. As we know, only 24% is recycled right now. It's collected and so some are refurbished and important components taken out. And then what can't be removed or separated is shredded, like printed circuit boards are shredded in order to extract the copper and other metals from the plastics and fibers. Almost all of it right now is sent to smelters overseas that are in Asia or in Europe. And then we in the United States would have to buy these back to get these metals. And so what we are looking to do with reclaiming critical metals is to initiate environmentally safe refining processes locally. And we're looking for sustainable alternatives that are effective, efficient, creating, and beneficial to the local economy. And we are looking, we've got a couple of different methods that we're going to be using, but one interesting path we are calling micro mining. And this stems from some work that I had done, a biodesign sponsored by Google in 2021. And there was 150 teams from all over the world and 15 countries that applied. And I applied with two colleagues, a designer and a robotics engineer. And we were chosen as one of 20 teams to compete. And we finished in the top 4 finalists. And the prompt was to envision a future where everyday devices live in harmony with nature in a symbiotic partnership. And we had a month-long competition for Google. And in addition, the solution had to be able to be implemented by them in their personal electronic devices within 5 years. And part of the results was making a 5 to 7 minute video showcasing the solution. And our solution was using the water hyacinth for micro mining of polluted waters to obtain copper for printed circuit boards. So I'm going to play just less than a minute of this, and then I'll have another little section. This part is going to be about copper and reclaiming copper. So I'll see if I can do this without mucking things up too much. Can you hear that? You can't hear that?
No, I can't hear it. You might have to put on your.
I have to take these out because I think these have to be out in order to hear it. Okay, we'll try again.
Our smartphones have a huge impact on our lives and lifestyles. Our relationship with them is so intimate that failed expectations can even change our mood. In a similar way, devices change our planet, in many places irreversibly. How can they fit better on Earth? Hidden inside our electronics, almost invisible, lies the impact of exploitation of heavy and precious metals. Traces inside a circuit board are commonly made out of copper. Smartphones, for example, contain around 15 grams of copper that comes from high-acid copper sulfide mining. This metal is completely reusable and recyclable without any performance loss. However, modern printed circuit boards, or PCBs, are quite complex. Can the electronics industry be reinvented?
Okay, I just wanted to play that little portion of it. And we'll come back here. And now I'm going to play another section. This is one specifically about the water hyacinth that is part of the video, but it's a little better quality that I had made at a different time.
Hyacinth is the fastest growing free-floating aquatic plant. It has great tolerance for food. This beautiful species has extraordinary capabilities to avoid introducing toxic metals and metabolism. The roots of this plant are able to uptake and accumulate heavy metal ions from water and sequester them as solid particles. Even in water, the roots exhibit similar motion properties. Water hyacinths have been used for the remediation of copper and other heavy metals in polluted waters. Those metals have not been for reuse. Said team researched and experimented with live water hyacinth capacity to absorb accumulate copper. These were exposed to a 100 parts per million copper sulfate solution, and the roots were examined in a scanning electron microscope. We were able to observe copper particles of 8 to 10 micrometers segregated.
And so in addition to being able to see copper sulfide, I did the same thing with shredded e-waste and metallic materials and got them into solution and was able to see other metals as well. So there is one thing to be able to use the materials themselves or the plants themselves, which is called bioutilization. So we could use water hyacinths, or we could emulate, which is called biomimicry, figure out how is the plant doing that and utilize that same, develop that same process for us to do it in a easier and a larger scale. And the water hyacinth isn't the only what we call heavy metal accumulators. So I want to talk a little bit about what they are, and there's other possibilities as well. And so there's three here. There is lichen, which takes metals out of the air. Water hyacinth takes it out of water, and the fishing spider takes metals out of its diet. So I don't know how many of you are familiar with lichen. They are a symbiotic organism that has fungus as the body and algae or cyanobacteria photosynthesize and make the food. And they are on 8% of the terrestrial surface of the Earth. They use substrates of rocks, trees, the forest floor, and they're an air plant. And one of the first organisms that I studied in the biomimicry program was this orange lichen that I had collected in Montana. And I looked at it in an electron microscope, and this shiny area, I was wondering what it was. And in the mode I was in, I could see different atomic number elements here. And the bright areas are heavier. And so I thought, well, I wonder what this is. And I never expected that I would see almost pure tin. And it turns out that lichens are natural miners, and so they take very fine amounts of ionic metals that come in and is absorbed through their skin, and they accumulate it and they store it extracellularly so they can live in areas that are polluted, and it doesn't, they don't poison themselves. And so that's the first example. And the second here, the fishing spider. I was fishing on the Manitou River on the North Shore, and I ran into this giant spider that's about 3 inches in diameter, so quite a few centimeters. And the fishing spider can walk on water, it can dive under the water, and it can actually eat minnows, and its fangs can inject it with a disabler and an enzyme and enable it to kind of suck and eat the whole thing. And I later caught one of these and I watched it molt. And the molts are actually a perfect replica of the spider, including the fangs. And this is a molt fang that I put in the electron microscope, and it again has this bright area that means it's a heavier element. I thought maybe it was calcium or something. I just was doing an exploration, and I found out that it is zinc. So they have zinc-tipped fangs. So there are, and I never knew anything about these, but it's amazing that they would take zinc out of their diet and utilize it in this way. And I'm throwing in an extra one here because potatoes grown on the Iron Range, actually potatoes will uptake iron in them. And I found this in my grandmother's a box full of recipes that the Iron Range Resources and Rehabilitation Commission during World War II published this book because they were encouraging people to eat potatoes that had high iron because they weren't getting enough meat. And this had all kinds of recipes, potato fondant. So there's many organisms that do this. So coming back again to the water hyacinth, that's something where biomimicry would be the next step. We are looking at two paths when we have our company Reclaiming Critical Metals. One that's looking at electronic waste recycling, and another that will be probably a secondary, we're just beginning, is polluted waters or spent mines. And this is where it would be particularly useful to use some of these nature solutions that we could mimic. We'll mention one more thing about this. We initially had applied for a DOE grant. It was called the E-Scrap Prize, and we were going to investigate the biomimicry of some of these heavy metal accumulators. We ended up not getting the prize, but part of it would have been working with a national lab, which in our case would have been Lawrence Berkeley National Lab, because they had a technique, soft X-ray tomography in their synchrotron, that would allow you to dynamically watch this whole process that would go on cellularly. And we contacted them again, even though we didn't win the prize, and they said, yes, this would be a perfect application. However, we are being shut down. We've lost all our NIH funding, and so they were closing it down, and they may be able to do a different time, but unfortunately, that's something that we're going to have to pursue in other ways. But I just wanted to mention that, the ramifications of some of those things. So in summary, we are working, I didn't mention this too much, on a bill to stop mine waste from entering the environment, and hope to get something going in the legislature next year, the next session. And copper is not iron. Copper is very different. You think of mining being that if you're mining copper, you're mining iron, that they're the same. But copper is very low grade. It's toxic, has a short mine life. It risks sulfuric acid flowing into the environment for thousands of years after the mine is closed if water treatment stops for any reason. And it's especially high risk when you have a lot of foreign companies that have had a very poor track record with this. Copper already in use, and there's $60 billion a year that we are losing that goes to landfills. I mean, we have a lot that can be recycled and can continue to be recycled, and we can develop jobs on that jobs can be provided for an infinite time period. And we can draw inspiration from nature and provide non-toxic, sustainable mining solutions. Thank you.
Thank you very much, Sue. So while people are formulating questions, I have questions about what are the next steps and how far along is the biomimicry research, or are there other researchers that are working on it? But I've also put into the chat a document that just has a lot of links to different labor reports and human rights reports on Glencore. Glencore is the company that has bought the company that is going to run the proposed, or hopefully not going to run the proposed copper mine in Minnesota. And since to go over it all would be a completely different meeting, I'm just going to mention that they have human rights and labor rights abuses, court cases against them for bribery, court cases against them for tax fraud in many countries around the world. There have been miners striking against them in Colombia, in Canada, in the Congo, in South Africa. There's also been in Colombia, some paramilitaries have testified in court that they were hired by Glencore to violently put down strikes, violently like remove people from land so that they could have it for mining. So, you know, some of these things they deny and some of them they don't. And it's also interesting that internationally they can be held responsible for bribery by their subsidiary companies, but not for human rights abuses. So if a company they own, say in the Congo or somewhere else, commits a human rights abuse, they can claim that they didn't know about it, but that's not the same for corporate crimes or discretions. So if you want to do further research on that, you can download that document, or if you have trouble with that, I can send some of the links. I've also included in that a link to the Natural Resources Committee. So if you are in the United States and you have a representative on the Natural Resources Committee, you can please write to them and let them know that there are alternatives to mining. There is research being done. We would like that research to be supported. And there's also a note at the very bottom, there's an article that mentioned that the Department of Defense actually has been given a fund for copper reclamation so that they could use recycled copper instead of mined copper. But I don't know quite a lot about that yet. And it also seems like the law may have been written in a very vague way so that it might not really be enforceable. So just a note if you would like further resources. But in the meantime, are there particular questions about the data, where it's coming from, or where we're going next, or Sue's lab? We will be here for a few more minutes for questions.
I was wondering, Sue, about the lab actually, as Sarah just mentioned. Is all your research that you presented about this particular project done in your lab? And are there other researchers, or where basically you're occupying the lab with this particular research? Is that your focus? Is a curiosity of a lab, how a lab works?
Okay. Should I stop sharing my screen, or what should it? Yeah.
Yeah, sure.
Okay.
Yes, we see each
Okay.
other better.
Yeah. Okay. So I have, yeah, I'm kind of wearing multiple hats. I mean, typically you wouldn't make a presentation like this, but it was sort of a flow with how this has all gone. I started with Lichen Labs. I got a master's in biomimicry, and I was working for Medtronic in medical devices, and I decided I wanted to go this new route, and I built a laboratory. It's primarily with microscopy. And I have researched many different things. I've been working with a architect in Canada on acoustic panels based on different organisms in nature, including like the scales on a moth, because bats have sonar and they hit the moth, and moths have actually developed evasion strategies in order to absorb the sonar. And so there's been a number of different projects that I've done. I started out doing imaging for medical devices and doing some biomimicry, and have moved to, I'm doing both. But on my own, I've done a lot of research as I see things, because I'm always curious about everything. And then when I have equipment now that I can look at it, I start following my curiosity, and I've found a lot with the other area here with metal hyperaccumulators. And then the Google challenge came in, and I did all the research for that. so in my lab, and I've had multiple interns, but I am very small. Okay to be bigger, but it's kind of a challenging new area that a lot of people don't really understand necessarily the value of, and I'm trying to show that in more ways. So yeah, I did all the research on that, and then found other people that were interested in the potential of using it for reclaiming critical metals, and then we have tried the grant route, and now we're looking at some other funding, and having kind of this organization that may do electronic waste, and then potentially, as we research this more, to be able to do mimic organisms that could pull it out of polluted waters.
Thank you.
And Sue, you had talked about working both with architects, with engineers, and with artists. Do you want to talk about some of those different collaborations or potential collaborations?
Yeah. Well, I've in addition to the work on doing the acoustic panels, we're also looking at, could call it managing fluids. It's looking at energy use in existing buildings, and how we might change the way that buildings use energy. And we've been looking at all kinds of different natural models in nature. And so we kind of, when there's a challenge or when we notice something, then we can look at how has nature solved a similar challenge, for instance. So there's some work there. And then I did, I've worked with academics with a significant study looking at structural color. Many of the bright colors that you see in nature, in butterflies and fish and peacock feathers, are caused by the interaction of light with the structure and iridescence. And I did a big study with University of Minnesota looking at butterflies and moths, and what makes white, what makes black, how different they are, even within similar species. And so I've done some special studies with them. I did an artist residency with someone who was interested in diatoms, and they were making an art installation where they wanted to have different reflections with structures that looked like diatoms. You can see diatom blooms from space. And she spent almost 2 weeks here, and she got a for this, and we did light and electron microscope work with diatoms, and then she utilized some of the findings in the structures that she was making.
And how is your interest in what you've spoken to us about received elsewhere? Have you been able to present it in your region and having more conversation at different regional levels, or how ideally also about the mining and all that movement, how open is the conversation, or how difficult, or who are your allies? Besides, we have seen some logos, let's say, but in general, how the conversation in your region goes.
Yeah, well, kind of in our hat of Northern Lakes Scientific Advisory Panel, we've presented this information at multiple places. And I recently did a very similar presentation to the Tamarack Water Alliance, which is a local group that is really interested in trying to protect the environmental area. And so I did a very similar one. And of course, we work with people like that are environmental advocacy groups that are in Minnesota, And we've made presentations and had discussions with them and trying to do some things with the legislature. But it is not very popular. I really wanted this to be different. This presentation is different because I've never presented my own personal history or about my family, but like connections to the Iron Range. It's not popular to talk about. There is a lot of acrimony between people who are for mining and people who are for the environment. And I think a lot of people don't understand the complexities of how you can, what's appropriate in what places, how it can be done, how different kinds of mines are different. I mean, and a lot of like natural ore mining, iron mining was quite different, it had a lot of differences to even some of the taconite mining, and even more differences now to copper nickel mining, and looking at the area that we come from, and people. I mean, when I worked for U.S. Steel, I left because I was laid off with 1,000 other people, and that's common that you have ups and downs, and the area is very depressed. I grew up and graduated from Virginia High School, and the town was 12,450 at that time, and then after the big layoff, we're down in about 8,000 something, so and a lot of people, when new mining opportunities come in, they think of jobs and they think that that is the ultimate. And so it is, people have to understand a little bit more about, do you want mining or not mining, about what it is, where it is, how they do it. Is this 10 to 20 years and you want to take the chance of ruining a very vast, pristine area? And so I think it's always more complicated than people want to make it out to be. And what I hope people will do is be open to hearing what it's all about and making decisions based on the facts, and the facts for particular areas. And I think that's one of the hardest things, is let's have an open dialogue and talk about it. Do you really want this for our area? Do you really? If you really understand what's happening? And so
And are there, sorry.
Go ahead.
No, I was wondering if there are data about health repercussions that are very specific that might touch in toxicology.
Yeah, especially that the people don't that creates higher levels of fish, and that has big health consequences and is upsetting a lot of people that eat a lot of fish, that because it's a way for people who don't to supplement their diets. And so the people on the Iron Range are the possibility of a significant percentage of children that are born with high mercury levels, and so that's very concerning. And
it's a global risk and issue, right? I was in Peru about gold mining, and for indigenous population is the same with mercury, and they're trying there. And I heard of, it's a shared concern, and I wonder if who could be the international campaigner for something as broad as mercury in that. I don't know, Javiera, if you have a thought on that. I point at you now. Javiera is a researcher in such topics.
Hi, Sue. Hello, Ilaria, and everyone. Nice to see you all.
Good to see.
Yeah, so so I'm a professor at UCSB, Sue, and I know Rupali Phadke at McAllister, who's been involved. Yeah, so she's probably part of your networks, right? Yeah. Mining in Chile.
Oh,
The Berkeley pit that you showed was created by the Anaconda company that has done a lot of the copper mining in Chile as well, and is responsible for many similar pits over there. So yes, it's a very global issue. I had a specific question about attribution science that I'll come to, but just to answer very quickly to Ilaria's question about mercury. I mean, there's a lot of international advocacy around mercury. There's an entire UN program. There's the Mata Convention, and mercury is one of those really stubborn pollutants that, despite really huge coordinated international efforts, very little, relatively ineffective results on the ground. Graduate students who's now professor at the University of Washington, research PhD thesis was about, and so hopefully he's working on the book and it will be out within a few years. But it's and then one of the problems has to do a little bit with what Sue was talking about now at the end, the going from sort of very has been received. And then I'm also curious, this is such a complex watershed, and it's kind of at a key location in these bigger watersheds, and there's a lot of industry in this, in this whole area. So how do you get questions around how do you isolate the impact, of Glencore, of this or that, and versus saying, oh, we can't actually distinguish if it's the farms or the this or the. That's what how a lot of these studies are received in Chile. This sort of relativizing the results and saying, oh, we can't actually attribute things to this specific activity. So I was curious to hear your thoughts about that, because I don't often get to ask a scientist that question. Thank you.
Well, I guess you would say that there are other viewpoints that have come out as well, kind of like what you said, and there have been other studies that, from what we could tell, they are saying that like sulfur is just part of the environment. There, okay. So I think that partly why I thought this would be great to do this on a wider audience. I mean, you have a wonderful audience here, because I don't think we're able to present at this kind of level. And there's been discussions. We have things in the NPCA database, but right now the NPCA, like as far as sulfate goes, there isn't any regulation stopping the mining effluent from it goes right into the watershed, and it's monitored, but nothing. There is no minimums or maximums or to look at in the legislature, and I might not have made that clear enough, that's what really needs to be done. And we're just talking right now about these tailings that are the waste rock that happen to have sulfides in them and aren't the future if they do this copper nickel mining that they're trying to do. And so it's very complicated. And so the copper nickel mining would bring a whole new set of issues. But going back to some of these, the sulfur, there are a lot of people that just say, well, that's the way is in the environment, that there is sulfur in the environment. There's sulfur in some of these, or and there's organic material that it could still methylate, and they don't even mention sulfur, and they don't mention the fact that that mining pollutants will exacerbate this. And that's what was really great about the data that we've put together. And I'm just one of the cogs in the wheel, that we've gone together as a group and done all of this water testing. And you can see where the green dots are and where the red dots are and where the flow is. And it's really hard to argue. And it's gone through accredited laboratories. And so I think people, it's like, have to take a look, have to acknowledge this. But some studies have not realized that are contaminated by mining and called them controls. And because they're in, you don't realize the flow. I mean, here we followed it for 175 miles, and then, but if you're in flow not far from the mine, it is not a control. Is not control, and that's been that, and they've been perpetuating a whole different line with this, that it's in disagreement with what we've been finding.
So you're saying, Sue, that they're using like already heavily polluted water as the baseline instead of clean water.
They're using polluted water as a baseline. And I'm going to who's doing I mean, there's some that's in the news. You can easily find if you do any research on it. But
are there next steps that you would advise for us?
well, I yes, because I still feel like it's hard to get people to realize what's happening, and if everybody sees this and sees this, that we can do something. Don't have late. Just now. And so we should, that's what I think about it.
Do we have any other further questions?
Oh, this is Angelique. I'm actually Sue's wife. I'm just going to comment about the local region here, in that what's so difficult is that there's really just kind of the history of mining, and I think it, so we need to for jobs on the Iron Range. And that's the message. We don't have to say stop mining. I think we can say, hey, we have alternatives to mining that can create more jobs. That's the message we need to somehow get through.
And that these are different types of mining. The iron mining is really a different than the copper nickel mine. Understanding that.
So we would be like creating requests for more funds for this type of research for.
Well, I think educating, we have to talk more to the people on the range, because our legislators, even our Democratic legislators, like Grant Hochfeld, who is our St. Louis County kind of our district representative, is for mining. Amy Klobuchar, you know, because they know that there are a lot of people on the range, they, you know, that want jobs. And so we have to, I think, educating and having more community awareness or somewhere, and educating them on alternatives to mining. We don't have to say stop mining, you know.
Right, and it's the new type of mining that is really the most threatening. So it's not with copper, nickel, and they aren't necessarily going for that. So I mean, I think there's room for understanding for what this all entails. I think we just need to have more discussions. And with what we would need, honestly, I think we need more funding for going e-waste recycling to do that. And I think we need to have legislative action in order to do this 100% e-waste bill so that everything gets recycled. And that is a huge provider, and especially being able to do it locally. And we have some possibilities. We're looking at some direct things we can do, and we just need to have more information. And then there's some of this new research, which honestly, if we kept up with even some of the funding that we already had, I've lost a lot of jobs and possibilities just because someone lost their NIH funding or someone lost their NSF funding. And those people would have used me for things, and now that's not going to happen. So we're not in a very good time right now for science funding or for research funding, fortunately.
I was just going to add on sort of on the local jobs discussion. High Country News, which is an environmental magazine published out of, I think, Utah or Wyoming, they're based. They've been publishing a couple of articles on how difficult the new mining jobs are. So, for example, there's this push now to reopen coal mines, and they're having a really hard time hiring because young people don't want to work in the coal mines, or they see it as just a, you know, very temporary job and not a career that they want to do. But also, and there's been very little, it's one of the things I struggle with in Chile. There's been very little in research, and there's good reasons for this, on just how precarious mining jobs have become. And how they're being also replaced by automation, and so there's fewer and fewer of them. And so in many ways, this whole juxtaposition is much less attractive than it used to be, right? And so people think jobs as in sort of, you know, the old more, back when blue collar jobs were well paid and were unionized, and that's not the reality anymore. So that might be a place to look, High Country News, and see what kind of reporting they've been doing in other parts of the Western US and in other sort of mining and post-mining communities throughout the West.
I'm also noticing in the comments, Michael was noticing that there could be jobs for reclaiming the pollution. I don't know, Michael, if you have any comments on what that might look like, or if there's been more information on that.
There is not an effort to do that right now, but June and July, some people from this area went up and made photographs of all the tailings basins. They flew from Ely to Coleraine and Silver Bay to Hibbington, all of them, and they're really bad. And they really can't be left like this. I don't know if there's money available for that either, but there'd be another industry because these things are leaking terribly.
Yeah.
And it would be like,
yes, that's exactly what we want to do with reclaiming critical metals. And I know that there's Jeff Hansen out there who's another guy he is working on this same issue for looking at how we can do things with pollutants from tailings. And so I think this is coming, and it's just a question of getting some funding on it and continuing some of the research. I think it is going to be the future to clean things up and to take the metals out, which is what nature is very effective at doing. And also with the e-waste, being able to have better ways of separating between these different materials, which is what we're working on, and that we can do that and continuing to get everything from mining.
I appreciate the nature lessons also because of their positive impact, I would say, in going and suggestion of Angelique of the kind of the communication criticality aspect, and the fact that we need to find ways to communicate in a simple way, very complex elements, and in a positive way, right? Because people get scared easily and they switch, right?
Yeah.
The quick and I know that not everything can be communicated, and it's kind of a self-reminder of such thing. But the fact that, and nature is a good ally in that, right? Looking at a spider that does extraction or potatoes or a jacinth is very uplifting in a way. Maybe it's a simplification to some if you don't bring them through the chain, but it's still, I find that unfortunately others are so good in communicating on the direction of the wrong that we need to get better in communicating in the positive way, the direction of the right. So yeah, if there is anything, and I don't know how to do it, straightforward, but I think that's also a challenge with all this funding because they're not really coming back anytime soon, right? So how do we keep going in communicating in a simple way, in a way, but that we can keep doing it, right? And in pills and in this social media world that exists and we cannot escape, but also allows us to say what we think. Because this censoring and this kind of, it's difficult to publish a paper or an article that goes in certain directions, right? So we need to find ways, though, to, with a smile, still say what is important for the environment and therefore for all living organisms, including us. So yeah, that was a thought about communication and
that it is a huge challenge. That's where I struggle all the time because trying to communicate about biomimicry or what nature can do, and you have to carry it all the way through. And very few people, a lot of people who are practicing biomimicry are looking at research that other people have done. And I've wanted to, another project that I was trying to do is, because I have developed methods for how do you start by looking at nature, how do you examine it under light microscope, electron microscope? How do you carry it all the way through and try to abstract the mechanism and do all of this? And what kind of people do you need? What kind of equipment do you need? And my idea was to put this all together in a research hub and franchise it, and like Genius of Place, that it would be done in different areas of the world, and understanding how the organisms in your area are tackling the problems in your area and how you could mimic various aspects of it. And taxonomic research, that kind of research doesn't get funded, according to the university professors. But they thought there could be this middle ground. So you could go through all these organisms and say, hey, Now I've got this organism that is particularly unique, and then you might be able to connect in. So then the university could take this to the complex level that you're talking about, and continue that on. And so I don't know. That obviously is a very difficult thing to have that happen, but that's how I would see a way to get some of this nature-based research, because it has to be on the ground research instead of just trying to figure it out from looking at research papers.
Yeah, I do very much appreciate the direct intimacy of your research with like your home and place where you've spent your life.
Right, right.
It creates a different relationship to the information, everything you found and how you find it. So I think that's an example for all of us to think about wherever we are.
I think we are hitting the 90th minute.
Yeah.
So maybe
We should be getting to go. And very, very glad we could make this connection. And I hope this is a conversation that's first of many. We'll learn a lot from you. Hopefully we can spread some good information about positive possibilities. And again, like reach out to your representatives who are on the Natural Resources Committee if you're in the United States. Let them know that there are alternatives to mining that maybe they don't think we know about. Ask for them to be funded.
Yeah.
thank you, Sarah, for reconnecting with Sue and bringing this conversation to us today, and to Sue for sharing all your thoughts or many of your thoughts. I'm sure you have more. But and NAHR is a small organization, but we try to do this and to find moments and places also at the residency to further develop projects such as these and others. We are very tiny, so our abilities are limited to certain spots, but we are really interested in the subject, and the good news is that minerals will stay on for another year, so these type of conversations will be able to continue, and even if we are in different parts of the world, we can keep connecting and sharing. And if there is more coming in your mind, please reach out to us. And thank you everyone for showing up today in a midsummer day for most of the world, or the northern hemisphere, and in the south hemisphere I think they are asleep, so they might see our recording, Sarah, later on. So thank you again from us, and yeah.
Thank you very much, everyone. And thank you so much, Sue, for taking the time to put this together, and all of our conversations where you've helped me to understand better what's happening.
And thank you for having me.
Thank you. Bye-bye.
Bye-bye.
Bye, everyone.